Hey everybody, and welcome back to another fun and exciting Algebra 1 class. Today's lesson, we're going to be on lesson 5.5. That is found on page number 172 in your book, 172. What we'll be doing today is talking about kind of dealing with the systems of equations that we've been talking about the last couple lessons. But now, how do they apply? How can we actually use these systems of equations in, honestly, everyday life? And you might think, I would never use a system of equation in everyday life. Well, you might be wrong about that. And I will show you a couple word problems where you might be like, oh yeah, I guess I could see where I would actually use that. You could use it in the grocery store. You could use it different places. Okay, so here we go. Um, all word problems can be solved, basically in different ways, but we're going to find a repeatable process that we can do and we can solve these. So here's what we want to do. And we've been going through these all years. We've been getting to word problems. We want to read it for understanding. We want to try to figure out what it's saying, right? And then we want to represent the unknowns. Now, in these ones, there might be multiple unknowns. And so we have to make sure that we get all the keywords, we identify everything that we're looking for. Number two, write and solve. So then we're going to write our equations out, and then we're going to work through solving our equations. And then lastly, we are going to state and check the answers. All right, so let's just get right into it. There's not a whole lot before we jump right into it. So go ahead and look down here on the screen. You can look in your book on page 172 if you want to follow along there. All right, so here we go. The sum of two numbers is 71, and their difference is 13. Find the numbers. So really we have two separate equations going on. One of the equations says the sum of two numbers is 71. The other equation says the difference of the two numbers is 13. So what we want to do is, this is the first time that I'm going to let you represent these numbers with an x and a y, because now we've showed you how to do it. So if we say the first number is x, and then the sum, remember the sum, is plus, and then the next number is y, and then make sure that you remember the word is always going to be equals, and then 71. Now notice here we have the difference. What's the difference? Well, we have x minus y is equals 13. Okay, so when you add them together, it gives you 71, and when you subtract them, it gives you 13. Okay, so we can use a system of equations. Notice we can use a couple different ways to do this. One way is by using elimination. I like the elimination method here because the y's actually eliminate right out of the gate, and we have 1x plus 1x. Remember, we're adding here, and so 1x plus 1x is 2x. Those cancel, equals, and then we're going to add these together, and we're going to get 84. Okay. And then this is fairly simple math. We're just going to divide both sides by 2, and we're going to end up with x equals 42. Okay, now the way that you would check this, now that's x. Remember, we have to have y as well. So the way that you get y is you just plug it back in really to either one of these. So 42 plus y equals 71. We're just going to subtract 42 from both sides, and that's going to give us our y. Y equals, and when we do that, we get 29. So y equals 29. Now, to check those, let's use this one. Let's use this one to check it. So we would say x, 42, minus y, 29, equals 13. This is this equation right here. And then we just say, does that actually equal? So when you do that, you get 13 equals 13, and it does check, and that is the correct answer, okay? So we're just going to write them, we're going to stack them up, and then we're going to either use substitution or elimination. We'll get the same answer either way. All right, let's move on to the next one. Here we go. A number is one more than twice as large as another number. Twice the smaller number added to 3 times the larger is 59. Find the numbers. All right, so How are we going to do this? Well, again, we're going to do the same kind of process that we did on the last one, and we're just going to kind of, make some things and make some things happen here. So let's do this. Let's call the larger number y and the smaller number x. So small is x and the large is y. Okay. So let's write the first one. A number is more than twice as large as another number. So let's call that's the y, that's the big number. So the big number, is one more than twice as large as another number. So that equals twice the other number plus 1 because it's one more than. Okay, so that's going to be plus 1. So there's my first equation. My second equation says that twice the smaller number is x. So 2x added to 3 times the larger number plus 3 times the larger number, that's y right here, okay, is 59, equals 59, okay? Now you might say, well, our x's and our y's aren't really lined up. Well, what I would do with this one is because we already know what y equals, we already have a substitution that's ready to happen, right? So we can just go ahead and substitute this in for this y right here. So now in the new equation, we have 2x plus 3 times 2x plus 1 equals 59. And then we're just going to solve that. So distribute this through. We're going to get 2x plus 6x plus 3 equals 59. That's going to give us 8x plus 3. We'll move that over by subtracting 3 from both sides. And we'll get 8x equals, it's going to cancel. And then we're going to get 56. And then we divide both sides by 8, and we end up with 7. And there we go. We have our x. Now that we have our x, we can kind of put it back in. You can put it anywhere you want. Probably be easiest if we go into this one. So we would have, let's change the color here so you can see it. And we have y equals 2 times, what was x? 7 plus 1. Now we just do the math. So y equals 14 plus 1, y equals 15. So there's our two answers. Now we can go back and check those. How do we check those? We can put them back into this one if we want. So 2x, so 2 times 7 plus 3 times 15 is supposed to equal 59. And then we just see if it does. So 2 times 7 gives us 14, plus 3 times 15 gives us 45, equals 59. Add those up. 59 does indeed equal 59. And because those check, we know that we did our problem correctly. Okay? And you still might be doubting me. You might be like, I don't know that I'll ever use this. Okay? Let's do one more. And let's see, because maybe, just maybe, we could actually use this someday. All right, so we go to the grocery store and we find out that cashews, type of a nut, right, are $10 per pound. And they will be mixed with almonds, which are $7 per pound. We want to make 75 pounds of the mix that is worth $8.20 per pound. How many pounds of each should we use? So the first thing that we want to do is, instead of using X and Y this time, let's use C for cashew, and then let's use, A for almond. Okay, you could use X and Y too if you want, but we'll use that. So what we want to do is let's make the basic one. So here's the basic one. We're going to have one mixture that is just cashews and almonds, and that makes 75 pounds. Okay. Again, we're not getting into any of the information yet. We're just saying we have one mix. This is kind of the generic mix. We have cashews mixed with almonds, and that gives us 75 pounds. Okay. So cashews plus almonds equals 75 pounds. Okay, because it says cashews. Don't worry about this yet. Don't worry about this yet. Okay, so cashews will be mixed with almonds to make 75 pounds. That's what we did. Okay, now the next one we want to make is the one that kind of gives us all the information in here. What is that? Now it says that the cashews are $10 a pound, the almonds are $7 a pound, and then the total per pound is $8.20. So all that information is very important for this next step. So we're going to say that $10 of cashews plus $7 of almonds is going to equal what? $8.20. $8.20. But not just $8.20. It's $8.20 per pound. How many pounds did we have? We have 75 pounds times 75. Okay? When we do that math, we'll just go ahead and do this math right here, and then we'll get rid of that. Okay? So just do that on your calculator, and you actually come up with 615. 615. So when we multiply those together, we get 615. Okay? Now we have our two that are ready to go. Now on this one, it might make more sense. I don't know how it makes sense in your mind, but it makes sense in my mind to multiply this by -10. Because if we multiply this by -10, we'll get that to cancel. And 10 is really easy to multiply by. So we could also multiply by -7 right here to get this to cancel. But 7 is harder to work with than 10, so I'm going to multiply by 10. So let's create a new equation with this one right here, multiplying everything by 10. By -10. -10c plus, well, minus 10a, because we're distributing this to everything, equals 75, well, -750. -750. Then we're going to add all those things together. The c's are going to cancel. That's what we're looking for. We're going to end up with -3a equals, and then when we do this, we'll do 750 minus 615, and we end up with 535, 135. And that is a negative because that one's bigger, so -135. Okay? All right. I think the book does it the other way. The book actually does it by 7, which is fine. We're going to get the same answer, trust me. Just going to look a little different as we're doing it. So we're going to divide both by -3. So if you're following along in the book, you might be like, you're losing me. Well, I just did it by -10 because in my mind, which, whatever, maybe in your mind the 7 worked better. In my mind, the 10 worked better, so I did it by 10. The book did it by 7. It doesn't matter. All we're trying to do is make our elimination here. That's going to cancel. We're going to get A equals. Those negatives are going to cancel. 3 goes into 135. We can come over here and do that if you want. That's going to go 4 times 12, 1, 15, 5 times 45. And so our A is 45. So what we would do is we can come back right here, this easy math right here, to get our C. So if our C plus our A equals 75, then our C plus our A is now 45 because we figured that out. Plus 45 equals 75. Subtract 45 from both. And we're going to end up with our C equals, that cancels. And then we subtract there, so we get 0, 3, and that C equals 30. So again, you might be like, I would never stand in a grocery store and do that. Well, let me give you an example of where I've used things like this before. Like fundraisers, if you want to raise X number of dollars and you need to know, well, how many candy bars do I need to sell versus how many bags of chips? Or how many hot dogs or how many pieces of pizza, whatever you're selling, you can figure out because a piece of pizza costs $3 and the hot dog costs $2, for example. Well, if I want to raise $800, how many of each do I need to sell? Or if I sell X number of hot dogs, how many slices of pizza do I need to sell? So I've used that with fundraisers before. You can use this. This does come in handy. Trust me. Okay. So sometimes you wonder, why are we even learning this stuff? Well, one of the big reasons we learn this stuff is because we're just sharpening our brain. We're just actually making our brain work better, figuring out how to solve problems. The second answer is we actually do use this sometimes. And so it's not something you're going to use every day, but it's something that when you put it in your brain, when you know how to do it, you know how to figure things out, you will be able to solve problems better, and you will get better jobs. You'll get people will look at you and be like, how did you figure that out? Well, I used math. And they're going to look at you like, what? So learn this stuff, and this stuff will help you as you cruise through life. That's all I've got for you. Hope you learned something there. If you missed anything, slide it back, watch it again. See you later. Have a good one. Bye bye.